In 11.6, we move on to geometric sequences and series. So a little reminder here, arithmetic sequences, they had a pattern, and their pattern was adding and subtracting a common difference. Alright, so it was the same number over and over again, and that acted kind of like a slope. In a geometric sequence, we are not adding and subtracting, we are going to be multiplying or dividing by the same number. So instead of it being called a common difference, it's called a common ratio. Alright, so an example of this would look like 1, 2, 4, 8, 16. Alright, here I multiply by 2. And I'm multiplying by 2, and I'm multiplying by 2, and I'm multiplying by 2. Or I could be dividing, so I go from 1 to 1/3 to 1/9 to 1/27 to 1/81. Every single time I'm dividing by 3. These will be written differently, so since it's common ratio instead of a common difference, we are going to be writing R. Alright, the R for multiplication is going to be R equals 2, whereas in this case, since I'm dividing by 3, it's going to be 1/3. If you're dividing by 3, you're multiplying by 1/3. So for multiplication, it might be a whole number, and for division, it will probably be something that looks like a fraction. So here is your general equation. A sub n equals a sub 1 times r to the n minus first power. So I need a couple pieces of information in order to write my rule. I do need to know my first term, and I also need to know my common ratio. So let's look at a couple of examples. If this is my sequence that I am given, I need to first make sure that it is geometric so that I can use this formula. So I am consistently dividing by 2 every single time I'm dividing by 2. So that would mean I'm dividing by 2 here, and I'm dividing by 2, and I'm dividing by 2. Alright, good. If I got to this last term and it was 3 instead of 2, then it wouldn't be geometric, because that means for the last term I wasn't dividing by 2. But here I am. So my common ratio here is 1/2. If I'm dividing, make sure that that 2 is there on bottom. And I am also given my first term. A sub 1 is equal to 32. So my rule, if I were to ask you to write a rule, make sure you put in the 32 and the 1/2. 32 times 1/2 to the n minus first power. We do keep that n in there because I need a place for an input, and I also keep that as a sub n for my output. Alright, and there is my rule. If I were to ask you for my, let's say, a sub 3, my third term, what would you do? Replace n with 3. 32 times 1/2 to the 3 minus 1. And you follow through PEMDAS. So I have to deal with my parentheses and exponent first before I multiply. Do not multiply first. So I have 32 1/2 to the second power, which is 32. We are not multiplying by 2, we are raising 1/2 to the second power, so we're squaring it. So 1/2 times 1/2, it's 1/4. And your final answer should be 8. A sub 3, your third term here is 8. And what's that? 1, 2, 3? That's our third term. And that works out. Alright, it is 8. We can just confirm that. Let's look at another example. Here we have to do a couple more steps. So you plug in what you know. A sub n equals a to the first power, or sorry, a sub 1. And my common ratio is 3 and minus 1. Okay? But I am given this point, so that means if I plug in 4, a sub 1, 3, if I plug in 4, that means I should get 54 as a solution. So I do have one unknown at this point, which means I can solve for a sub 1, my first term. 3 to the third power, 54 equals a sub 1. 3 to the third is 27. And I would divide each side by 27 and get a sub 1 to equal 2. So now I can officially write my rule. A sub n equals 2 times 3 to the n minus first power. Make sure we have the proper r, I do, and the proper a sub 1. There is your rule. If I were to ask you then for the, let's say, third, a sub 3, you would replace n with 3. 3 minus 1. 2 times 3 squared. That would give you 2 times 9, which is 18. Alright, a sub 3 equals 18. And just like you would be with arithmetic sequences, you would be able to use this as a point as well. 318, this would be 1 comma 2, and you have 4 comma 54 given to you. Those would be 3 points that you could plot. This shouldn't be a straight line like arithmetic. It should probably have a little bit of a curve to it. Alright, please feel free to see me early in the morning or email me with questions.